Energy transfer in chemical reactions. A chemical reaction is the breaking apart of an old bond or a new one coming together. And the reactants are reacting to become the product. And the reactants have the same mass as the product. That is the law of conservation of mass. So the product has the same mass as the reactants had to become the product. All the chemicals reactions in the human body are called metabolism. There's potential and kinetic energy. Potential energy is the energy which is where it could become something, like the food can be when it becomes something, and energy cannot be destroyed or created. So that is the law of conservation of energy, but it can be converted. It can become potential energy in the form of food, can be converted into kinetic energy, to walk, to talk, whatever. And there are exergatic reactions, and exergatic there's at the end less energy in the products, because there was a lot of energy released when new bonds were formed and only a little absorbed when they were broken apart. And endogenic reactions, there is a lot of energy in the products because there is only a little released when they are put together and a lot absorbed when they're broken apart. And now we need activation energy to do it all, but it is the case that we're having kinetic energy, molecules and ions and so on, they're moving around, and when they collide together, then we can have that valence electrons, they are bounding or breaking and doing things, that makes them the chemical reactions, but we need activation energy to move like that. And it can be made easier, but these reactions are happening more likely by having just more of these molecules, or a higher temperature when we're also moving faster. But there's now the idea of catalysts. In the human body, these are enzymes, and these enzymes, they are lowering the activation energy necessary to do this, bombing together, changing the electrons, the valence electrons to do a chemical reaction, and giving or getting energy, whatever. And also do they orientate them rightly. They also are more likely or better, or only when it is possible, if they come together in the right, hit each other at the right spot. And that is according to Gerhard Toga and Sarah Grabowski's Principles for Anatomy and Biology book on several pages, for example 34, 35 and 36. But this is no medical advice. Hi and welcome, I'm trying to learn biochemistry. Today, energy transfer in chemical reactions. And after we've done that, we're going to do extensor carbon analysis trend. Each chemical reaction involves energy changes. And energy is the capacity to do work. Two principal forms of energy are potential energy. This is energy stored by matter due to its position. And kinetic energy, the energy associated with matter in motion. Chemical energy is a form of potential energy that is stored in bonds of compounds and molecules. So chemical energy is stored in the bonds. An exergonic reaction has that the energy released when new bonds form is greater than the energy needed to break apart them. What do we mean with energy released? Now we're having back in mind that energy cannot be used up, can neither be created nor destroyed. If it is released, what could we mean with energy release? Do we mean the amount of energy gets higher? But where is the energy? In the form bound. They are saying that after this exergonic energy, which releases more energy when new bonds are formed, has less potential energy in its product, which are these formed bonds. So the energy is not in the bonds. Is it not transmitted into the bonds and therefore released? Where is it then? Endogenic reactions. They are absorbing energy. The reaction is absorbing energy. Why should the energy absorb it? Does it have to be done away? They use more, they bind more, do they mean? Endogenic bind more. But if energy binded means we're absorbing a lot of energy when they are bound, and therefore the products have a lot of energy, that would fit. The exogenic reactions how can be energy released? Where is it going? They don't bind so much. Because when they're breaking apart, then the part of the exogenic reaction where some things are breaking apart is great, needed to break them apart. And so they are releasing. And there was little energy bound. There was a lot of energy released, then bound. I don't get it. I don't understand where the energy is released to. Where is it going? Where does it come from? It's basically the most fundamental, simple questions I ask into it. It's just one or two very simple, fundamental questions. So it's nothing about complexity. It's just that we will continue with just memorizing it. The one does what that we are, one does the part which is not important, but with which, when we have it back in our mind, we can, when we have someone saying what energy release means, on what energy we're talking about, where it came from, and where it got from. It came from the food, but if it comes from the food, and now new molecules are formed, new bonds are made, and where's the energy now released to? It's not released energy there, no, it cannot, because the product has less. So they were not released into the product, so they are just there. But how can they be released? They have always previously, if not in the bond. We have in the food. If you don't declare it to be a bond. How can it be now released by coming another molecule? We're just going to memorize it. There are exogenic and endogenic reactions, and as we want to explain this also with the graphic a second time, the same thing, which is very easy to understand. It's just that one does wet and wet, wet. For example, with arrows, that one does wet and the other one does wet. We easily understand we easily can answer a question, what does produce something with more reactants, with more energy, and what does produce some with less? We can answer the question easily, but it doesn't make sense to answer the question. No, absolutely not. It makes sense to answer the question. For us it does, because with the knowledge back in mind, we will understand it as soon as someone gonna tell us what happens with energy. Exogenic reactions, where a lot of energy is released, X, so a lot is released, and endogenic, a lot of energy is taken in. And because a lot of energy is taken in, endogenic, the product at the end has a lot of energy in it. Is it correct? The product has more energy. Now in exogenic, a lot of energy is coming out, and the products have at the end less potential energy. It's totally simple. But this was not my question. And the reason for it is, by exogenic, when new bonds are forming, there's a lot of energy released, more than it is needed to break them apart. The energy is just totally aware in the human body. We're talking about that. And by endogenic, there is only a little energy needed to form new bonds. Is it right? That must be very wrong. When new bonds are formed, in endogenic reactions, the energy released when new bonds forms less than the energy needed to break apart out bonds. With other words, now the graph is explained. It must be less. So new bonds are forming, only a little is giving off, and forms are breaking apart, and a lot is giving off, is giving out. And therefore more is in the product. Now there's a lot energy given out. A lot given out. Now, the endogenic reaction, the energy released is less. Why is there now less released? So there's a little given away. And much more given away than the breaking apart. And there's a lot of given away when we're breaking apart, and therefore there's at the end more energy in. The energy released new bonds form is greater, so there's a lot of released. The energy released when new bonds form is greater than the energy needed to break apart out bonds. So plus energy is released as the reaction occurs. There's energy, and that energy causes the one thing to make new bonds, which releases only a little bit. Where is it released to if there was something which had to be absorbed in the first place? And if there's more released than absorbed, why should we release now more? Yes, more energy when we're releasing, but why should there be more energy in the products if they're releasing more? Where is it released to? Into the products? Exogenic reactions release energy in the products. Now it is the other way around. Exogenic not into the products. Where to? Endogenic release into the products. Where is it released into, if not into the products? The products are the end result. The products are the new bonds. The out bonds who have taken part, yes, that is also a chemical reaction. Is a bond breaking apart, one bond becoming two bond, also reactant to product. The starting substance are known as reactants, and the ending substance are the products. Let's assume that also, but we don't have time. If you were here for biochemistry, you can go directly to the next part of biochemistry, where we apparently not just memorizing these three facts, these are just three names, but apparently still trying to understand it. If you want to go, you can go. If you stay here and participate in the external couple nurse drift dynamics, so that you own this. I hand the fist next to the body and bring them down and up. and fists, and down and up. And now you can use a sock, a towel, or a t-shirt. You press onto it. If you participate in this, it is the opposite. Press onto it and bring the fist down. Now we're having a few rules. If there's pain, stop immediately. Only as far as you can go with a little bit of effort, and don't overdo it. We just want to strengthen, not to exhaust. And last one up. And change. And again down. And change. There's a lot of energy released, we say, as kinetic energy. As what energy is the potential energy? Because the potential beat energy has to be in the product, to be outside. So no pain, only as far as it goes. And to be inside. And outside. Other hand. Inside. And press on the top and down. Down. And down. And then with your hand press, what is the use of a whole chemical reactions if at the end there's less energy in the product? At your hand, just press. Maybe because the energy was used up. That is the whole idea. It was used somewhere. It was the extensor cover analysis. If you were here for extensor cover analysis, when it was it, I thank you very much. And until next time.